Uh, Good evening, everyone. Welcome to 11th live session for the course Usability Engineering. My name is Neelarnab Dutta. I am a PMRF fellow from Department of Design, IIT Guwahati. So, in this particular lecture, I will be discussing about key concepts from week 11 lecture videos, and this will be a doubt clearing session. So, please be interactive in the class. So, you can use the chat box, or you can also directly interact with me via the microphone. Okay, so let's start with some recap from the last couple of classes. So in this particular course, we started our journey with the introduction on usability engineering. So there we try to understand what are various scopes of usability engineering, what are the elements of usability engineering, and what is the procedure. So in the procedure, we have learned about user-centric design process, and also we have learned about design thinking process. Okay, design thinking process. Okay, and then we learn about various user study techniques, both qualitative as well as quantitative. So we like contextual inquiry, interviews, and based on the requirement, we decide whether we choose a qualitative study or quantitative study. So we have already discussed when we have to choose qualitative interviews and when we have to actually look for quantitative surveys. So those things we have already discussed. Then in couple of classes we have discussed about how to analyze various data that have been generated after your user study. Okay, and that involve analyzing user activities from user studies as well as cognitive processes that user go through while performing certain activities. Okay, so I gave several examples of banking context as well as military context of using some healing devices. Then we discussed about competitive analysis and benchmarking, which is after we finalize our user study, we then arrive at some sort of requirements. Then we started ideating. So we have discussed about various. I have discussed about various techniques like scamper, brainstorming, etc., etc. And in detail, I have described scamper. And after that, I have discussed about various ways how designers should think while generating ideas or concepts. So that involves divergent thinking, convergent thinking, etc. After that, we arrive at the design phase, so detailed design phase. So in the detailed design phase, in the last class, we have discussed about micro interactions, which involve designing trigger rules, feedback, as well as loops. So now we will move into the design evaluation phase, which will involve user testing as well as heuristic evaluation. But before going to user design evaluation, I'll cover a last topic remaining in the design phase, which was information architecture design. Okay, so let's start with information architecture design. So what is information architecture design? So you might have heard about this term. Okay, so if you remember the Garrett model that we have discussed in the very first class, there also we have discussed about information architecture a lot of time during the structuring phase. Okay, so as I said, the Garrett model comprise of 5 layers, and it actually represent how UX design is involved. So as we move from bottom to top, the things became concrete for the user, So the information that is available at the surface level are more concrete in nature. That means uh, those are finalized information and which a user can understand, and the information below are more abstract in nature, because these are not something, the four layers beneath the surface layer are not always visible to users because of certain reasons. Sometimes it is because the format in which the graphic design, the GUI, is designed does not exactly represent the wireframe. Okay, or sometimes it does not show the information architecture. So as I told you before, information architecture is about, okay, sorry. So information architecture is about defining the structure of a user interface. Okay, so in the structuring phase, what we do, we try to define all sort of interactions and how those will be integrated together. Okay, and in case of websites or mobile application, we need to arrive at some sort of sitemap. Okay, similar to this. Okay, so this is what we call as information architecture. Okay, so basically information architecture is about organizing various information, various essential functionings, and group them into various structure and hierarchies. So first step is organization. Then what we do is we structure the information, and then we do labeling of them. Okay? So information architecture is the structuring phase in a UX design process. Okay. So once we arrive at a information architecture, from there actually we can generate wireframes, and then we can develop the final graphical user interface. Okay, so so if we look at the information architecture, we cannot determine what will be the output graphical user interface, because at information architecture level, the GUIs cannot be recognized. Secondly, whether we are designing a website like Amazon, or whether we design a interface for a device, the information architecture will be looking the same. Okay, so it will be the same. So same architecture can be used for a mobile device, which will be a hardware, or it will be some sort of it can be also used for computer computer application interface, and the same information architecture also can be used for designing websites. Okay. uh, so information architecture is not a part of the on-screen UI, as I told you. Okay, however, it is the first step where we combine the user research and the ideation outputs to take shape. Okay, so basically here is the first step where the various ideations that we do after user study and benchmarking, this is the first step where actually we combine those ideas, information, and try to give a shape to our final solution. Okay, so this is what is information architecture. So the goal of information architecture is to match with the mental model of the user. So I think you might have remembered what is a conceptual model and a mental model. So a user has a mental model of a interface. Okay, so how it will interact. So for example, when someone design a website, okay, and when he see a particular tab, there are some sort of expectation from the user side what may be underneath that particular button, but that particular drop down menu. Okay, so if we can match that, that means we have actually matched the mental model of the user. So deciding on what should be the label as well as what sort of contents will come under a label is the purpose of design, and that's why we design the information architecture. Okay, now before designing information architecture, we need to understand four components of information architecture. The first one is the organizational scheme and structure. Okay, now when we first collect data and we try to group data into different pieces of information, so one of the thing we need to consider is like how we will be arranging the information, whether we will be arranging into a structure which is more like a hierarchical in nature. For example, this is a hierarchical nature where information is hierarchical but it is also narrow and deep. So page A, which can be one website page, will have two options to move forward. Okay, and then again it will branch out into two. So page 2 or the other option will again expand into 2, and like that we will have a page B underneath the second flow of activities. Okay, so this way of designing the structure is what we call as narrow and deep scheme. Okay, so this is narrow and deep in terms of the structural layout. The other one is broad and shallow. Okay, which is like we have all sort of website information in the front page, in the home page, as multiple tabs, and generally it is not possible for mobile applications, because in mobile application we have a very limited size of the interface, so making tabs of that many numbers is really difficult. However, for desktop application probably we can have that, and in most of the cases we design information architecture in combination of these two. Okay, we do not go as narrow and deep, and again we do not make things broad and shallow, depending upon whether we are making an interface for for a mobile application or a desktop application. We decide our scheme and our structure. Okay, so that's the reason why we come up with the responsiveness of a website. And while designing a responsive website, we decide on different scheme and structure for mobile application as well as for PC application. Okay, so both will have different layout and schemes. So this is the first component we need to take care. The second component is the labels, the labeling system. So what sort of labels we are looking for. Now this is to determine how we will be presenting the information. So how many of these elements will be requiring? Because based on our user study and ideation, probably we may have generated a lot of information and data. And when we are designing an interface, okay, and interface can be static, or a interface can be a static website, or it can be an active device interface. Okay, so designing for active interfaces, in the last class I have discussed about how we design trigger rules, etc. Now based on user requirements or functional requirements, we need to decide on what sort of interaction buttons we will be requiring, what should be their labels, right? This is for devices. So if we have a device, so then we will decide on what sort of buttons, how many buttons, and how many sub activities you will be requiring to perform. Okay. Similar to that, when we are designing websites, we need to actually figure out when we are making tabs on top, so what should be the name of those tabs. So this all depends upon how, so what is the nature of the data and how we categorize those data into certain groups. So here's an example of a website where the labels are like interact, view, browse, and search. Okay. So if you click there, probably it will go to a page 2. If you click here, probably it will go to page 3. So this decision on the nomenclature is what is the labeling system. Okay. So this is the second component we need to take care. Third is the navigation system. Now navigation system is once we have arrived at a structure based on certain schema, once we have done our labeling and have decided on the hierarchy or the schema or structure hierarchy, now we need to see how we'll move from one element to another. For example, in case of Amazon website, you may not see all these buttons at one go. Probably only about us and few of the initial buttons will be visible in the front end at the UI level. Okay. Now when you click, probably it will straight jump to certain area. For example, there may be an advertisement of garments, and it's like a quick sale offer for garments, and if you click, it will directly go into the garment section. Okay. Similarly, you can also move into some area, for example, which can be like already existing uh, apparel section, but when you actually add something to cart, it will go to the order page. Then when you actually place a order and then you click make payment, probably it will move to another system which is not visible for you, but it is something that is happening behind, and it is actually taking you to some other website or some interface like Google Pay. Okay. So this way, like the planning of how the user will navigate between different elements and how the overall activity or functionalities will be performed, that is determined by designing various navigational schemes. Okay. So this is what is designed here, and this is the third component. Okay. Design of the navigation system. Then the fourth component is the search system. Now whenever you make a commercial website, for example Amazon. Okay. So what happened, like there is so many categories and so many elements exist in the information architecture, it is not very easy for someone to actually go through entire hierarchy of information architecture and try to look for you the item. Okay. So you need to provide some sort of quick search option, and also there should be some efficient way how one can navigate. So for searching actually you need to provide some sort of search box, which is generally present in most websites. That became a standard in today's interfaces. Now, while designing a user interface, you need to think about how to index various elements, the levels that you have created, because there will be a lot of levels for website like this thing Amazon. And whenever you introduce new items whenever a new seller joins, he may name his product in a different way. Okay, so different name, new name. And when someone search here, for example, if I want a blue sky, so blue sky can be actually the blue sky, or it can be some cloth name, apparel name. So how the system will recognize which one to show? So depending upon how the system index the various available items and elements within the site data, the system will give you the results. Okay, so this is always a active activity where in the back end the system automatically index the various information which are newly introduced into the site data. Okay, so whenever the user will put certain keywords, sometimes you may see there are also help documentation come. For example, if user just starts B, the other, a lot of names that will come, that may be a hint for him, so that the user do not have to type the entire word. Okay, so if you type the next word like BU, probably it will show butter, butterfly, like that. So that option is also needs to be present in certain websites. So this particular component, how we actually plan all of these things, is called the search system. So basically we have these four systems: organizational schemes and structure, labeling system, navigational system, and search system. So now once we have decided and planned these things, then we can actually go for information architecture design, and then we can actually go for wireframing as well as UI design. Okay, so here I am describing like what are the various activities of information architecture design. Okay, the first activity is content creation, content inventory. So here what happened, once we have decided on our labels, okay, for example the title pages of various content. Okay, then we need to create the URL, basic information about what is there inside, and all sort of elements that will be there under this particular title page. So this entire process of creating the contents is what is called content inventory. Okay, so we need to provide this information to information architecture designer, and they will then start developing these things into some form of spreadsheets like this. Okay, once they decide, once they design all these information, the second step is to audit the content. Now auditing is done by experts, and this is to check the usefulness of the content, the accuracy, the tone of voice, that means the language that's been used, and the overall effectiveness of the various content that has been put there. So here, for example, if someone identified something needs to be changed, then they can mark. Okay, so this is like how the experts put comment and suggest how the contents needs to be changed. So after that, what has been done is information grouping. So in information grouping, this is like the start of designing the hierarchy or the structure, where similar informations are grouped together with technique, for example card sorting. So if we can group a set of elements into under one category, then we'll give a appropriate label for them. So this particular process is called information grouping. We also try to see if there are relationship between different elements, though they do not fall under one category. Okay, so based on relationship or based on their properties, you can group them. And also in this particular phase, we also decide on how interactions will be there. So for example, from the opening page, if someone wants to go directly into one of these elements, then probably we can group them into one particular group, because that may be a quick search option for a new user. Next is taxonomy development. So taxonomy development is similar to labeling. So taxonomy development means defining the labels which have some standards meaning. Okay, so we need to use always standardized naming convention when we are designing labels, because that will make the website more intuitive, because user will have their past experience about the label names, so probably it will be easier for them to navigate. And there are different hierarchical taxonomy options available. So when we actually do card sort, we may arrive at different set of groups. Okay, now how to arrange these groups is again a matter of defining the structure. So while defining the structure, when we actually create a label for these groups, we can decide what will be the name of this particular label and what all will include into it. This is very much similar to how we create selective code in the thematic process. So in thematic coding process, as we have discussed during I think think alert protocol. So after think alert protocol, we used to do thematic coding, right? So there, when we created open codes and then grouped together into Excel codes. So imagine these are various Excel codes, okay, and their definitions are open codes. And now when we are creating label, basically we are creating selective codes and trying to define their hierarchy, where they will fall. So there can be hierarchical taxonomy where you have, a label called vehicle, because you name it as a vehicle, so these categories may fall within that. Okay, and then you have a hierarchical taxonomy. Similarly, there can be faceted taxonomy where you will have multiple hierarchies. Okay, but this is not hierarchy, like multiple levels parallelly running, and below that you will have the elements. Okay, so these are different ways how you can actually arrange the information in a website or in an interface. Okay, here's an example of a sitemap of a website. So sitemap is basically the information architecture, as I told you, and this is the term sitemap is used mainly to describe information architecture for websites, and for others generally like device interfaces, they generally use the word information architecture. Now, this is the information architecture or the sitemap for the Amazon website. And if you can see here, you have the Amazon, which is the home screen. And from the home screen, actually, you have this menu: My Delivery, Subscribe, Whole Food, Phrase, Alexa, Prime, Videos, Music as the first, key labels which will come in at the front page. Okay, then when when you go to menu, probably you can go to again home page and then go to your order. My deliveries, you can go to order tracking. Subscribe, you can go. So like this, we have followed a combination of faceted taxonomy as well as hierarchical taxonomy. So this is hierarchical in nature. If you see this particular flow of information, this is hierarchical in nature, and this way of putting information is faceted taxonomy, because they have common importance. That's why they are placed parallelly in the main website. Okay, and then even there is a separate option in the hierarchy where you can actually go for navigation, and there you will have search, notification, card, camera, Alexa. So these are provided at the top corner for additional sub navigation. So here is an example. Okay, so after we have designed our information architecture, the next activities are wireframing and GUI development. So we have already discussed this in the design phase. What is wireframing and how we do design wireframes, and what is GUI. So GUI is basically the prototyping phase, where I have discussed previously. You would make first low fidelity prototypes with paper prototyping. Then you make high fidelity prototypes, which are basically prototypes uh, which are similar to the actual product in terms of functionality. However, there can be also versions of high fidelity prototypes. There can be alpha prototypes, which are uh, developed for user testing. Then there can be beta prototypes, which are generally used for production prototype. So next is like as we see in the Garrett model. So this is the Garrett model. So once we have designed our information architecture, so first we arrive at the elements, and then we go through the process of designing information architecture. And once we finished, what we have at the end is the information architecture. Then what we do, we created the skeleton. The skeleton is basically the wireframe. So for example, here if we see the Amazon website, here is the wireframe. Okay, basically it's a template how this UI will be placed. Okay. So this particular rectangular box will accommodate some video. Similarly, you will have some sort of playlist here. Okay. So I think this is a wireframe for Amazon Music, and you will have albums, prime stations, prime analysis, etc. So the way how we actually create wireframe is basically just planning. So first you have the information architecture, where you decide that okay, the first page will have these three elements. Okay, then the second page will have these two elements. Okay, now designing the first page, this is the page one. Okay, and this is home. In the first page we have decided that okay, there will be three labels or three components. So now based on the requirement or based on the content, we'll be deciding like what will be the shape, or what how much area will we need for that particular content. So for example, this can be the area for first one for GUI, and then this can be the area for the second one, and for the third one this can be the area. Okay. Now if this is a information architecture for Amazon, now think like that this is a home. Now first one is music, this is movie, and this is like buy ticket. Now music, so this is the area where content for music will be displayed. This is the area where content for movie will be displayed. Then this is the area where you will buy ticket. Okay, now what happened when you actually click this, you will open another page. Now then you will move to this particular hierarchical content. Now you will now move down the hierarchy. Now there you need two content. Okay, so based on their requirement you can decide how much area and in what particular shape you will be needing that space. Okay, so probably if this is a movie and this is like Hindi movie, this is English, so probably you can decide on Hindi, this is English. Okay, so once we arrive at the skeleton like this, so this is information architecture, information information architecture, this is wireframe. Now once we arrive at the wireframe, then we can hire someone, or we ourselves can design on the graphics part of it. So you can actually create graphical content and then put here to represent Hindi movie. You can create some movie strip like this, which will be having multiple Hindi movies. Okay, then you can also create content for English movies. So this is an example how actually you the Amazon might have arrived at the wireframe and then they have created the graphical content. Now while designing these these e-commerce websites, one need to decide on that each of, while designing a strip, you need to think of that each of these are actually individual boxes that are in a rectangular long strip, because the content that has been displayed here actually brought from uh, different element within the hierarchy. For example, one is here in the hierarchy and one is here in the hierarchy. So this is probably from a consumer electronic, and this is from a medical device. This is something from a maybe something from a box. Okay, now this way of arranging information into a wireframe is always very difficult because of difficulty of indexing informations. So the common approach currently which have been seen in the industry is that generally people try to show similar category information in one particular strip. However, individual boxes can display different items at different point in the time. Okay, so for example, these are all fall under one level, one hierarchy, so it is easy for them to index and actually show one by one. The search or the search and pick algorithm will then pick any content within that particular hierarchy and then it will reflect here. Okay, because this needs some sort of algorithm and it should run fast. Otherwise, if you know the search and then pick is have to done in a within the entire hierarchy, then probably it will be very time consuming, so you will not see fast change in information. Okay. So this is how we do wireframing and GUI development. Okay, so so till here we have finished our the design process. So to wrap up, so what we did so far is like, first we did ideation with various ideation technique. Okay, and based on the user requirements and the ideas we generated, what we arrive at are various interactions by designing micro interactions, which I have already discussed in the last class. Then the next activity was to come up with a information architecture where we decide the structure of various information, how it should come, and then we do the wireframe design, and then finally the graphical user interface. Okay, now the next part is like to check whether the particular user interface or the interactions we have planned are, is this actually matching the mental model of the user that we need to check. Okay, so for that what we do either user testing or we do a heuristic evaluation. So heuristic evaluation, in today's class I'll be discussing about heuristic evaluation. So heuristic evaluation is a informal method of system usability testing. So usability testing means to check how easy a particular system is to use. Now, before we do user testing, or you can do also usability testing after user testing, but generally heuristic evaluation is done immediately after designers or developers come up with a system to check how the system met the user requirement based on their conceptual model. So the designers or developers, the team of designers or developer have their conceptual model, okay, and then they gave it to some experts, and the experts do a heuristic evaluation to check what they think. Since they are experts, what so the team which is actually developing the interface or the interaction, they try to see what will be the experts feedback on the particular design. Okay, now to check what all needs to be there, we need to have some sort of guidelines. Okay, otherwise what features or factors the experts will check? Because for every interface or every product, the interactions, the requirements which are technical in nature, and also they are different from system to system. So for expert, it is not easy to evaluate a entire system, so quickly. And for that we need some sort of design guidelines as well as principles. Okay? So these set of guidelines or principles which actually aid experts in evaluating a design is called, so these guidelines are called heuristics, and the process is called heuristic evaluation. Okay, now why this is called informal? Because this is fast, and without understanding how actually the system is functioning, an expert can evaluate a system. That's the reason why it is called informal. A formal method would be when actually the expert evaluate the system based on the parameters that are necessary for that particular system or interaction. Okay. However, this is informal because here we consider the system as a black box. So for the experts, the system is treated as black box, and the experts perform heuristic evaluation based on certain guidelines. Okay, and as an outcome, if the system outperform or if there are shortfalls these guidelines, then the expert will identify those shortfalls as usability issues. Okay, so based on those standard or generic guidelines, experts identify certain usability issues, and then based on that, the developers and designers again make design changes and further give it to the user heuristic evaluators to check the thing again and again. So this is a part of a iterative system design process, where the process continues till we arrive at a state where there is no such usability issues. Okay, uh okay, already discussed this. Okay, now this is different. The heuristic evaluation process, see, you have user testing and you have heuristic evaluation. Now when you perform user testing, you ask the user to perform certain task, and user may actually find difficulty in doing certain tasks. There can be various way how to detect the usability issues. Now some of them already discussed in the user study, like think aloud protocol can be used to understand user cognitive issues they faced. Then by looking at system log information, you may actually find where the system failed. Again, monitoring the user, okay, you can identify certain issues. So there are a lot of different interpretations required when actually we perform user testing. Okay, to evaluate a system, okay, see, user is performing a activity and user is actually giving some sort of reactions. These reactions, first of all, it can be varying from user to user. Okay, the reactions that the user gives, it will vary from user to user. Secondly, the nature of these reactions will be again difficult to interpret, because the processes that actually we use to recognize usability difficulties from user are not of 100% efficient or accurate, that it will give the right usability issues, because some of the cognitive issues are difficult to capture. And again, based on visualizing or the reaction how a particular user uh, give while doing a particular activity, it is very difficult to understand what sort of issues he or she might have faced. Okay. So user testing always require further interpretation after we collect the user testing data, and that again involve expert evaluation. And the data that are generated can be of varying nature, can be videos, things like protocol data, transcripted data, audio data. So there can be a lot of different data which needs to be interpreted for identifying usability issue. Heuristic evaluation, on the other hand, is a direct method. Direct method means experts directly evaluating a system based on certain guidelines. Now those guidelines may not follow exact, it's not may not exactly describe the system utility or system functioning, but those will be generic guidelines based on which some of the aspect which are common across various devices can be identified if there are usability issues from those perspectives. Sometimes heuristic evaluation does not work. For example, if you are making a medical device and there are some system level requirement for performing medical activity, so a heuristic expert may not be able to identify that system lacks that particular functioning, because those are technical in nature. That's why heuristic evaluation is an informal method where the user or where the expert considers a device or interface as black box. Technical requirements, functional requirements, those will not be verified using heuristic evaluations. Only those which are part of interactions which make a interaction more intuitive, more easy for user, those will can be verified. Okay. The process of heuristic evaluation, generally when we involve experts, initially individually multiple experts evaluate systems. So the data are initially collected individually, and then we combine the information. So for any such uh, activity, we first decide what sort of task or activity we are actually going to evaluate. Then we hire 4 to 5 experts and then give them the task of heuristic evaluation, and based on certain heuristics which you think are appropriate for your system, you ask them to evaluate, and then you combine the information. Later, after combining with the same set of experts, you conduct a constructive debate where detail level discussion has been carried out to check whether everyone agrees with certain heuristic violations or usability issues. If the expert team can arrive at certain usability issues as a confirmation, then you consider those as two usability issues, and then you report them to the team of developer or designer, and they will make the design changes. The thing happens again and again. So once again, the developer make those changes and then report to the evaluators with the new design. So the process continues. Now, how to conduct heuristic evaluation? The very first task is to know what to test and how, because different system may require different approach. Okay, for example, a speech based system may needs to may needs experts to evaluate the dialogue management, probably the heuristic which they used to check, for example, error prevention. So they need to relate how error prevention can be related to dialogue, how someone can make errors in dialogue. So some sort of level of interpretations are required, and that will depend upon what we are going to test and how we are going to test. Similarly, this is like the variation in interactions. Okay, so interaction varies. So if this is speech, then there can be just normal graphical user interfaces. So based on differences in the interactions, we can decide on how to test particular interface. And again, if we try to evaluate complex interfaces having multiple modalities, for example, a banking app can have activities for transactions or activities for this is, for example, transaction. This can be an activity uh, for example, this can be like beneficiary adding. So add beneficiary. Now, if you have developed a system, the user or the expert evaluation needs uh, so the task for which you want to do the expert evaluation needs to be decided first, whether that particular expert team of expert will evaluate the transaction part or the benefits beneficiary adding part. That needs to be decided first. Okay, so one will be based on what modality the experts will be evaluating, that we need to decide. Second, what sort of interaction required. Based on that, they need to decide on what sort of heuristics they require. Okay. So this is the first activity that we need to do while carrying out heuristic evaluation. So this is the initial phase. Then second thing is like you need to give details about users, the end user who will be going to use that particular application or system, and what are their goals, the context in which they will be using. All those information needs to be provided to the experts, because experts may not be part of your study when actually this particular project or activity has been carried out. So during your contextual inquiry, probably you might have generated data on patient or sorry people, and you might have created user personas. So those information about user persona might be useful, and you can provide that user persona details to the experts to understand like from from whose perspective they need to actually evaluate the system. Because if they think like for example, for certain heuristics like efficiency, they are experts and probably might think like that is not efficient, but from the user perspective they need to think. Probably for a user which we have no exposure to mobile application, that particular option which is which may be trivial for the experts may be necessary. Okay, so that's why understanding the user and understanding their context and requirement is necessary. So this is the second thing we need to do while conducting heuristic evaluation. The third thing is obviously the selecting evaluators. So normally 3 to 5 evaluators needs to be selected for heuristic evaluation, because this is again something where we see how many experts actually arrive at the same conclusions. This is again like majority wins, because we do not want to see or evaluate a system interaction based on one person's perspective. we will try to see if everyone understood the user at the same level. Okay, and then when we combine the information as we discussed previously, then we can see how much difference exists between various experts opinion. Okay, so that is the third activity. Fourth is defining the heuristics. Now there are different set of heuristics already existing, like Nelson's heuristics are there, which are commonly used for graphical user interfaces, and there are also different heuristics already provided in the past by scholars for for example, for conversational agents there are heuristics. For speech based user interface there are heuristics. Graphical user interface also there are many researchers who provided graphical user interface heuristics. So like that we can also have custom heuristics for our organization or our purpose, which actually we can use to evaluate the system. Okay, so here's an example of a heuristics. For example, you set a set of heuristics which are like guidelines, like something needs to be fast, needs to be carried out unconsciously, it should be automatic, it should be error prone. Okay, so these are like something which is should be slow, should not be conscious, effortfully learn. So these this is an example. Okay, so like that actually we can have some sort of rules or guidelines to check your device against them. So heuristics are generally are principles guidelines which are set for particular type of interfaces. In most of the cases you may heard about Nelson's heuristics because those are popular for designing websites as well as interfaces where graphical contents are required. Okay. There are also extensions of Nelson's heuristics for speech-based interfaces as well as tactile interfaces. Okay. So original Nelson's heuristics are for GUI, but there are extensions of GUI heuristics into speech as well as AI systems. Okay, so this is about defining the heuristics. That's the fourth activity. After that, you need to brief the evaluators what they have to carry out, and you need to describe like what are the various system level functionalities you have added and how it addresses the requirements. Okay, and you also have to provide them a scale to to check the severity of violations, usability violations. So you can use Likert scale. So Likert scale can be 3 point. 3 point Likert scale will be like bad, good, very good. For 5 point can be very good, good, neutral. Then you have bad, very bad. So like that you can give different scale to the evaluators so that when they identify certain heuristic violation, they can actually rate what is the severity of that particular violation or usability issue. Okay, so next is like as an initial activity you ask the evaluator actually to perform certain task. This is important. We conduct heuristic evaluation in two phases. You can do in multiple phases, but generally in two phases, because in the first walkthrough there are two walkthroughs generally carried out. In the first walkthrough you allow the experts to understand the activities, the flow of activities. Okay, and in the second walkthrough only you ask them to evaluate the system based on heuristics. This is done, this is for just activity carry out. This is done in order to make first of all uh, there are two reasons. One is to make the experts aware of the system functionality as well as the set of activities that are performed. Second thing is that is first logic. Second logic is that while doing activity, it is difficult to actually do heuristic evaluation. If you expert is new for a particular system to evaluate, then it will be difficult for him to first recognize what are the various features or activities or functionings exist in the particular activity, and then on top of that, parallelly he also needs to be carried out his heuristic evaluation, so which is difficult. So that's the reason why in the first go, in the first walkthrough, you allow the experts to conduct that particular activity without thinking about heuristics. You just ask him to achieve that particular goal, identify various elements, features within that particular activity, and then later you ask him to carry out heuristic evaluations. So this is the first walkthrough. Then the second walkthrough. In the second walkthrough, basically, they scrutinize individual elements according to heuristics, and they examine how this fits to the overall design, and you record the entire session, okay, without affecting the experts in the heuristic evaluation process. After that, at the end, you debrief the evaluators and you ask them what they have identified. And this particular process is, as I told you, first carried out individually. So individual experts, so these are expert, for example, expert 1, expert 2, expert 3. So they will have different, they will have heuristic evaluation 1, heuristic evaluation 2, heuristic evaluation 3, like that. So they will have different set of usability issues. Usability issues 1, you have 2 usability issues, then 3. Then you combine these usability issues into a pool of usability issues, and then you conduct a constructive debate, okay, with all the experts E1, E2, E3, and try to see in which all usability issues they agreed upon cumulatively, and then you identify only those usability issues where majority of them agrees upon, and then you gave them to the design team or the development team, and then you change the design. Once the design is done, you again reiterate this entire process. Okay, so this is the process of heuristic evaluation. Okay, so the last topic for heuristic evaluation is Nelson's heuristics. So Jacob Nelson's heuristics are very much popular for GUI as well as for interface design, for website as well as for devices. Now there are 10 Nelson's heuristic principle, which are visibility of system status, match between system and real world, user freedom, user control and freedom, consistency and standards, error prevention, recognition rather than recall, flexibility and efficiency of use, aesthetic and minimalistic design, help user with errors, help and documentation. So these are commonly used for graphical user interfaces as well as websites. Okay, so I'll go one by one in detail. So the very first heuristic is visibility of system status. So what it says is that when a person interact with a system, it should first of all provide immediate feedback. Okay, it should first of all provide immediate feedback. Second, it should inform the user about the status of any procedure, active or important information. For example, if battery is low, then system should actually give you the information. The system status about battery life, battery level needs to be reported to you with immediate feedback. So that's the idea of visibility of system status. Even if there is a downloading process is going on, you should be informed, like, okay, this is not a hang state, at least something is moving, so that you may recognize that, okay, this is in a downloading state, this is not an image or a picture. Second thing is like how much time it will require to make the download. At least it will give you some hint of information that, okay, that many times, or that it may take 5 minutes, 6 minutes. So that much of information needs to be provided. So system should inform you number of step left. For example, if you are doing a long multi-step process, and when you are in the middle of the process, you may not know actually when the process will end. Okay, then you may discontinue in the middle, because it's taking you 20 steps and you still don't know when the process will end. So in those cases, actually you will be requiring to provide those information. So generally, how we provide, if the system has 40 steps, we say 13 out of 40 completed. So these data will let, this kind of information will actually give you information or a hint to the user that, okay, I'm in the middle or first 25% of the process, like that. Also time left, how much time left needs to be reported. Okay, so this is the first heuristics. So while the experts evaluate a interface, they see during a process if there are certain areas where the system is unable to provide you information. Okay, and there are confusion whether the system is running or how much time it will take. So for those cases, the experts will give you will report the usability issue of visibility of system status. So here's an example. For example, time, Wi-Fi signal, battery life status can be visibility of system status. Then navigation with selected tab, okay, can be also. For example, here it is showing that it is active. Similarly, change of directions can also give you the indication that actually it is moving. A loading symbol with active, change in these dots will let you know that, okay, it is running. Or if there are some movement of graphical elements, then also you will recognize that it is in the running condition. Empty state, okay, so when nothing is there in the cart, you are informed that, okay, there is nothing in the cart. So this is also an important information which one need to recognize while they are shopping in Amazon. Okay, so these are various examples how one can track the violation of uh, these particular heuristics. Next heuristic is match between system and the real world. Okay, now the idea here is that people presume how the system would work based on their experience from past, whatever they have seen in their real world. So in while designing a system, it is always advisable that you use user language. You use the language that is familiar to user. You use the norms, values that are actually require match what is required. And even for making the images, you choose something based on user affordances from their past experience, which will make your system more intuitive in nature. Okay, so whether you are making a system intuitive or not from interaction, that is different thing. But from content wise, whether it's a grammar or the labels naming or visual information or icons, try to use information or content which can be easily recognized based on real world experience. For example, a recycle bin looks like a dustbin. A folder actually looks like a file folder. Okay, similarly you have for phone, book. Okay, you have similar physical world setup, diary. So you create similar symbols. Similarly for navigational compass, you use the symbol from the inspiration of a physical compass. So this is the second heuristics which can be considered. User control and freedom. Now, every system should have clearly marked emergency exist, because sometimes what happen, system can get hanged, or there are some issues may occur, some pop-up may occur, and at least some sort of control that needs to be provided to the user so that the user exist exit from that particular state. Okay. First of all, regarding the unwanted state, this is important. Second thing is, like, while performing any procedure, you should provide appropriate controls, because it is always desirable that when we make a system which is not a AI system, user should be in control state, not the system. Otherwise, user will not feel interacting with the device. And examples can be exit navigation anytime. So you provide this button. If you do not provide, then user will be facing difficulty. Similarly, when you accidentally delete some files, there should be some option where either you can undo, okay, undo some action, or recover accidental deleted files by placing them into recycle bin probably. So those can be user control and freedom related features. Consistency and standards. Consistency and standards means use same name, rules, protocol which has been used elsewhere. Okay, and also throughout your system use similar rules, name and symbols. Okay, so never confuse users with new terminologies, new words. Avoid using jargons. Okay, and avoid using visual or actions which are not available elsewhere, which are new. So that will make the life of the user difficult in navigating your device. So that is one. The fifth heuristic is error prevention. Now, error prevention is very important, and probably this is one of the most important heuristic that one needs to consider. There are two types of errors. One is slips, another is mistakes. Slips happen when the user tends to do one action and due to low attention performs another one. So this is more like a accidental error. Now here I am not talking about functional errors. Okay, functional system functional errors. This is error from interaction perspective. Okay, now second one is mistakes. Mistakes means when the user, because of mismatch of user's mental model which is a system's conceptual model, user interpreted something, and then misunderstood. There are misunderstanding in communication, and consciously the user performs certain action which leads to some error. This is what is called mistakes. Now you need to tackle both while designing interfaces. How? If first of all you should design the system in such a way that errors should be minimized, that is one. And also you should design the system that errors should be preventable. That means the system should inform the user about the error state. This is very similar to visibility of system status, but in case of errors, the system should give you information so that the user can prevent going into error state. For example, there can be pop-up like, are you sure you want to quit? Then the user can give me the confirmation, because sometimes by slip he can press this particular X button and whole download process can actually stop. So to avoid such slips, you need to confirm from the user, because intentionally also sometimes the user can might have, you know stop that particular process. So better to confirm from the user whether the user wants to cancel that process. Second can be when the user is typing in a message box, the number of buttons that can actually entered can be a subtle information, uh, which will let the user know that you cannot write beyond that many numbers of letters. So otherwise the user will keep on typing, and if that message will not get typed, then user will feel uncomfortable. It is again similar to visibility of system status, but more from the perspective of error prevention. Then another can be error pop-up messages. Okay, so whenever you click somewhere, some sort of red label comes, and that say that okay, you cannot make create negative number, you have to only add positive number. Okay, so this is done via constraint. So these two are constraint, and this is confirmation. Generally slips are taken care by confirmation, and mistakes are taken care by providing constraints, because the kind of intervention you are providing, they are actually providing constraint to the interface, that user cannot go wrong by typing more letters, or here typing different number types. This is like a confirmation. Okay, so error prevention is important. Then the sixth one is recognition rather than recall. Now there are two types of memories that user use while interacting with any interface or device. One is the memory retrieval process, which is the recognition, and the other one is the recall process. Okay. So these are the two different memory retrieval process. So recognition is something what a person is familiar with, and it can easily recognize that based on visual information. So the memory retrieval is shallow, so the information is not stored deep inside the person's memory, so it is easy to retrieve. The other one is other type of memory retrieval is recall, which happens when the information resides deep inside the person memory. For example, name, years of some guy, a birthday of your parents, like that. So those are information which generally needs recall. Okay, so what this particular heuristic says that use recognition rather than recall in most of the times, because this will make the interaction efficient in terms of time, because it will probably is difficult to recall something without giving any hint of that. So for example, if you ask in the interface, okay, what if you ask that question, choose the right temperature. Now user may not know what kind of temperature needs to be selected, but if you provide some sort of graphical help where you say okay, temperature can be from 50 to 60, which is desired one, then probably the user will know okay, I can select something between 50 to 60. That is something for recognition. Recall is if we have read in the past that okay, for particular procedure that temperature is required, or within that particular application, if you mention about temperature profile, some in some other page, probably that would be difficult for the user to recall and implement. However, recognize and implementation will be easier. This is an example, like when you ask someone to use two interfaces. This is like the old DOS interface where it's a command prompt and you need to type, which is not very intuitive. And the new one is more like icons, use of icons like Windows. Now this is more easy to recognize and this is difficult to recall. That's why we need to use such kind of interfaces. So this is about recognition and recall. Next is flexibility and efficiency use. Now this particular heuristics talk about that always identify the user requirement. Try to see if the user is an inexperienced user or is an experienced user, and try to help or provide efficient interface for both. Okay. Now effective interface for both. Now for novice user, probably you can create a interface having all sub steps. Okay. Now the interface which is very easy for novice interface, probably for expert in users that will be too trivial in nature, and he may get bored while using such a interface. So you should provide some sort of shortcut which will make the interaction of the expert a bit easy, a bit efficient. Another example can be like while designing a keyboard, and if a designer use Photoshop, you can actually provide some sort of shortcuts into it which will make the use of Photoshop a bit efficient for designers. So providing shortcuts to experienced user is the idea here. So this way we are making the interface flexible and efficient for both novice user as well as experienced user. So while designing website interactions or device interactions, we need to consider the the level of expertise, uh, which can be both inexperienced or experienced. Next is aesthetic and minimalistic design. Now this is something which define the beauty, the quality, or the information legibility of an interface. Now when we create websites, if there are already lot of content, generally in e-commerce websites we generally see lot of information, lot of advertisement, lot of data already exists. Okay, so it is really difficult in e-commerce website to manage information and also make it clean and uh, less complex. However, what you can do, you try to use the concept of aesthetic and minimalistic, and you try to make it more less sorry, make it less cluttered, use of color scheme which make it legible. You can make uh, colors which are appealing to the user, and overall the user will not feel the information are difficult to grasp or read. So these decisions come when we consider the heuristic, aesthetic, and minimalistic design. Now currently this is in trend, like people are trying to make everything very simple, uh, you know less colorful, simple shapes, but this is not always possible when actually we create complex websites or interfaces. But the idea is that the information, use only those information that are necessary, and when are using the informations, try to use color schemes or try to use techniques so that informations are legible to read and visualize. The ninth heuristic is help user recognize, diagnose, and recover from errors. Now, I already discussed previously as preventing errors. Now, preventing errors discuss about that first you prevent errors to happen, and if occurs, give some sort of prompt and allow the user to avoid any sort of error. Okay, but beyond that also you need to provide specific recognized features that user can use to recognize, diagnose, and recover from errors. Sometimes what happen, like there can be errors where the information are very vague. For example, a error type like this, commonly we see sometimes when we get such message, error domain error 20, we actually do not understand what actually happened. Rather better if we actually provide a more natural description of the error. Okay, so this particular heuristic means you design the error message in such a way that it is recognized, it is easy to recognize. So it's not about the task of preventing errors, it is about designing the information that comes when there are error occurs, so that the user can easily recognize, diagnose, and recover from errors. Okay, error prevention means prevent errors. First of all, make the system in such a way that there are no errors. Second is like if error occurs, inform, let the user know like error occurs. It can be slip, it can be also mistakes, but what all information will pop up, that design is described here so that the user can easily recognize. See, it is although error pop-up comes, user cannot recognize this. So this is a heuristics that one can use. The last one is help and documentation. Help and documentation means first of all you make the system so accurate and so effective that you do not need any sorts of help and documentation. That is first. Try to make the system intuitive, but if there are any sort of requirement, provide facilities so that user can refer important documentation, facts, and any tutorial that are crucial for doing certain activities. So help and documentation, so the usability experts will check in case if he face certain issues, if in case some novice user requires some help and documentation, are such facilities are available or not. So that is the evaluation what the users, these experts will perform. Okay, so that's the end of today's class. So what I have discussed so far in this particular class is like how to design information architecture and how to perform heuristic evaluation, and then also discuss about heuristic, the 10 principles, Jacob Nelson's heuristic principles for GUI design. And we use these for various purposes, both for website design as well as device interfaces. And that's it. So I hope this session was useful. So if you have any question, please feel free to ask. Okay, thank you.